Hello viewers, Ronald taking you through the story for A-level pure mathematics, and this video I'm going to go through the topic of parabola, which is under conic sections. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So before we start the topic, let us first look at the course outline. So math paper 1 is divided into 5 parts. The first part is algebra, where 2 questions come in section A and 2 in section B, and these are the topics. Second part is trigonometry, where 1 comes in section A, 1 in section B, and these are the topics. Third part is geometry, where 1 comes in section A, 1 in section B, and these are the topics. Fourth part is vectors, where 1 comes in section A, 1 in section B, and these are the topics. And the last part is calculus, where 3 come in section A and 3 in section B, and these are the topics. So the topics which are ticked are already available on this platform. So calculus is already completed, vectors is completed, algebra is, we are remaining with complex numbers, which is half ticked. Half ticked means that the video is available but it will be remade because of the quality by the time. So and trigonometry is also complete. So now we are working on geometry. After geometry, that's when we shall complete this part of algebra with complex numbers. So today we are going to cover parabola. So some students find problems with locating the videos which are already made on the platform. So what you do, at the end of the video, you'll always see these ones, we call them end screens. So this is an end screen, this is an end screen, and this is an end screen, this is an end screen. So these are folders, let me call them folders, where videos are placed. So for example, this is the folder for algebra. So if you want a video on algebra, you'll just double click on this end screen and it will take you to the videos at the end of this video. Not now at the very end of this video, this is just a display. Then this one is the end screen of conic geometry. So when you double click, it will take you to that. This is for calculus and this is for trigonometry. But you do that at the very end of this video. So at the end of this video, end screens will appear. So you double click on what you want and it will take you to that video. So now in this video we are going to cover parabola. Now parabola is part of conic sections. Conic section is divided into 3 parts, which is parabola, ellipse, and hyperbola, and all will be covered on this platform. So these 3 curves get their names from the cross section of a cone. So depending on the way the cross section appears, that is how you get the name of the curve. So we shall see the shape of the parabola, shape of the ellipse, and shape of the hyperbola in their respective videos. But for this video, we shall concentrate on parabola. Now, according to coordinate geometry, a conic section is defined as the locus of a point which moves so that its distance from a fixed point, now and that fixed point is called a focus, bears a constant ratio. Now that constant ratio is what we call eccentricity. We shall see these terms in details. To its distance from a straight line, and that straight line is called a dielectrics. So all these terms are very vital. The focus, directrix, eccentricity, they are very vital. And I believe we covered locus previously, later under the part of geometry. So this will be our straight line, and this straight line will be called a dielectrics. And this one will be our fixed point, and that fixed point will be called a focus. And now this is the variable point which moves, and as it moves, now for this case, for this parabola, that constant ratio is equal to 1. What does that mean? It means that the distance from here to here is equal to the distance from here to here for you to get that E as 1. So this is the formula for eccentricity, the ratio, the distance between the distance PS to distance PM will give you the eccentricity. Now when eccentricity is equal to 1, it means that it is equidistant. So these ones will be covered later in the video. So ellipse, when e is less than 1, that is an ellipse. When e is greater than 1, that is a hyperbola. But for this time, it is now parabola. So the fixed point S is called the focus, and the fixed line AB is called the directrix. We have already seen that. So now let's start with the equation of a parabola. So we saw what a conic section is. Now let's look at what a parabola is. So a parabola is defined as the locus of those points equidistant from a fixed point, which is known as the focus, and a fixed line, which is known as the directrix, as shown below, and its eccentricity is equal to 1. This is what you should always remember. Eccentricity for a parabola is equal to 1. Now let us look at the shape of a parabola. So if I have those axes, x-axis, y-axis, then that will be the shape of a parabola. As long as you see this, it implies that it's a parabola. And this one will now be called the directrix. This line x equal to negative a is the directrix, and this is the focus. This is a variable point on the parabola, and this is the locus of that point, and that locus is what we call a parabola. But we need to get the equation of a parabola. Now, in other words, we want to derive a certain formula. If you look at this, the good thing, the formula is available in your mathematical logbook. So if you look at your mathematical logbook, under the section of conics, there is this part of parabola and standard form, this. So this is what we want to derive. So we start from what we know, that the eccentricity is equal to 1. Then when you cross multiply, we shall get PS is equal to PM. So the good thing, we know the distance between 2 points, the distance between P and S, and the distance between M and P. So the distance between P and S is given by this, and between P and M is given by that. So when we square both sides, we shall come up with that. And when we expand, this gives you this, and this gives you that. And when I collect like terms, I'll come up with this. I think realize that it is in the form which is also available in your mathematical logbook. So that is the formula of a parabola, which you shall be using more frequently. Now there are different shapes of a parabola. Now in simple terms, a quadratic curve is always a parabola. I think you realize that here there is the degree of 2, degree of 2, degree of 2 in terms of y, degree of 2 in terms of y. So all quadratic curves have a special name, and that special name is called a parabola. Now the shape depends on the coefficient of this. For example, this x squared means that it is symmetrical about the y-axis. Then here, if this is positive, it will have a minimum point, and if the coefficient of y is negative, it will have a maximum point. Then this here, for this case, y squared means it is symmetrical about the x-axis, and when the coefficient of x is positive, it means that it will have that shape. It lies in the positive x-axis. And when it has a negative coefficient of x, it means that it lies in the negative x-axis. So those are the 4 shapes of a parabola. Therefore, for you to know the shape, you have to first look at the coefficient of x if it's in that form, or the coefficient of y if it is in this form. Now let us look at some of the terms used in this topic of parabola. So the first term will be the axis. So axis, this is the line about which the parabola is symmetrical. We have already seen that it can be symmetrical about the x-axis or y-axis or any other point. So the line of symmetry of a parabola is what we call the axis, or axis of a parabola, and it divides the parabola into two equal parts, and it passes through the vertex and the focus of a parabola. Now there are these two terms, vertex and focus. At least for focus we have some little knowledge, but this vertex we don't have any knowledge. So when you look at this sketch, for this case we say that a curve in this form, it is symmetric about the x-axis. So this line divides this curve into two, so that line becomes our axis. When it is in this form, it is symmetric about the y-axis, so this y-axis is what divides this line into two equal parts. Therefore that y-axis becomes your axis. Now it is not a must that it will always be the x and y axis which will be the axis, but what we know is that the axis will always be parallel to the y-axis or parallel to the x-axis, depending on the shape of the parabola, as we shall see further, because in this video we shall look at how a parabola is sketched. Now the vertex is this point where the curve turns. For example, here it was moving downwards. Now when it turns and starts moving upwards, that will be the vertex. We shall see the division in this video. Then here also, if you look at this, it was moving this direction. Now at this point it turns and starts moving in this direction. So that is what we call the vertex. The focus, we have already seen it, but we shall also define it in this video. So that is vertex. Now that is axis. And how do you get the axis given the equation of a parabola? So what you do, you look at the term, at the variable which is squared. In a parabola, either y is squared or x is squared, but both can never be squared. So if y is squared, come and equate it to 0, and when you equate it to 0, get the value of y, and that will be the axis. If the x term is the one which is squared, equate it to 0, and the value of x will be the axis. Now, why did I say that it is not always a must that the x and y axis will be the axis? It is because here it's not a must that they will give you y. It can be, for example, y minus 1. So if it is y minus 1, it means that the whole of this is equated to 0. Y minus 1 squared is equated to 0. Therefore, in that case, it will be y equal to 1 here. That is why I told you that it's not a must that the y-axis and the x-axis will be the axis of the parabola. But what we know is that the axis will be always parallel to either the y-axis or to the x-axis. Then now we shall go to vertex. This is the point where the axis cuts the parabola. This point is located midway between the focus and the dielectrics of the parabola. Now that statement is very vital. Let us look at the sketch again. Because when they tell you to sketch a parabola, they will also tell you to locate the vertex, focus, and dielectrics. Therefore, the vertex is the point where this axis meets the parabola. And they told you that that point divides this point, which is the focus, and this point here where the dielectrics cuts the axis at equal distances. For example, this is distance A, and this is also distance A. So these terms are very vital because they will be used when we are sketching. So if similarly, if it is in this form, still this will be the focus, this will be the dielectrics, meaning that the distance from here to here is equal to the distance from here to here. So now, how do you get the vertex given the equation of a parabola? What you do, remember we said it's a point where the axis cuts the parabola. So it will come here. If the parabola is in this form, the axis will be this. So what you do, you ask yourself, when y is equal to 0, what is x? So when you get the x coordinate, those will be the x and y coordinates of the vertex. Therefore, in this case it is 0, 0, therefore the vertex will be 0, 0. If the curve is in this form, then the axis will be here. Therefore, you ask yourself, when x is 0, what is y? So when you get those two values, that will be your vertex. Just like I said about axis, that the axis is not a mass that will always be the x and y axis. Similarly, even here, the vertex is not a mass that will always be 0, 0. It will depend on the axis or the line of symmetry of the parabola, as we shall see when you do some worked examples. So that was vertex. Now we shall go to directrix. Now the directrix is a fixed line. I think you already saw this. Fixed line located a units from the vertex. Therefore, if the parabola is in this form, then the directrix will be x equal to negative a, as we saw it here. For example, if you look at this, remember we said, let's start with this one. This point is a units on the positive x-axis, and the directrix is a units on the negative x-axis, meaning that the x value of this point will be negative a, because this is 0, 0. For this case, the y value here will be y equal to negative a. Therefore, for you to know the directrix, first look at the shape of the parabola. So if it is in this form, it means that x equal to negative a will be the directrix. And if it is in this form, it means that y equal to negative a will be the directrix. The next will be focus. Now we are looking at the terms used. Then after that, when you start worked examples, you'll realize, you'll understand better what these terms are. So focus. This is the fixed point located on the axis of the parabola a units from the vertex on the opposite side of the directrix. I think you realize that always the directrix and the focus are on opposite sides of the vertex. So if in this case it is the vertex, directrix when it is on the left hand side, focus will be on the right hand side. Then here, if this is the vertex, and the focus is upward, then directrix will be downwards of the vertex. Now, how do you get focus? Focus, this one is standard. If you look at this mathematical logbook, when this is the curve, or when this is the equation of the parabola, the focus will always be a0, and the directrix will always be x equal to negative a. If you interchange, it means that even here they will interchange. For example, if this is, as we can, let's see here, so you already seen from our mathematical logbook that if it is in this form, the focus will be in that form. Now when they interchange, it is now x squared, x which is squared. That means that here you are going to interchange. What was here goes here, and what was here goes here. That's why you get 0a. That is focus. Then focal chord. Now this is any chord. We already saw chords in circles, so this is any chord that passes through the focus. So a chord which passes through the focus is called a focal chord. Therefore, when you look at this sketch, there is this line joining from point P and P1 and Q1. By that line, if you realize, it passes through this focus, so that makes it a focal chord. Similarly, this other line P2 Q2 passes through the focus, and that makes it a focal chord. Also in this case, as long as it passes through the focus, it will always be a focal chord. Then now we shall go to another term, that is latus rectum. This is a focal chord perpendicular to the axis of symmetry of the parabola. From the above sketch, P2, Q2 is the latus rectum. So if you look at this, like we said, there are two focal chords, but a special case when the focal chord is perpendicular to either the x-axis or y-axis, that becomes a latus rectum. So this one is a focal chord, but because it is perpendicular to the x-axis, it becomes a latus rectum. Similarly here, this one is a focal chord, but because it is perpendicular to the y-axis, it becomes a latus rectum. Then now we shall go to length of latus rectum. Remember, with the parabola are of two shapes. There is when it is y which is squared and when it is x which is squared. So if it is y which is squared, for a parabola, this line x equal to a is the equation of the latus rectum. As we saw it here, for example, when you look at this, for this line, the values of x are constant, and that will be x equal to a. When you look at this, the value of y is constant, and that will be y equal to a. Therefore, if the parabola is in this form, then the line of the equation of the latus rectum will be x equal to a. Now what we are going to do, we shall get this x and substitute it here in the equation of the parabola. And when you do that, we are going to come up with this, and this gives you, and when you put square root on both sides, you will come up with plus or minus 2a. So what does that mean? It means that when you go back to the sketch, it means that from here up to here is 2a, and also from here up to here is 2a. Now length of latus rectum means that the length of this chord from here up to here. Therefore 2a plus 2a will give you 4a. Therefore you shall come and conclude that the length of latus rectum will be 4a, and this is magnitude, because you can either start with this minus this or this minus that. Therefore you have to remember that to put a magnitude, and magnitude means that whatever is negative becomes positive. Now the good thing, we know that y is equal to 2a, therefore it implies that the length of latus rectum will be 2y, and you substitute the value of y. So here we shall come and say that therefore the length of latus rectum of a parabola this is equal to the magnitude of the coefficient of x. Because here when you look at this parabola, coefficient of x is 4a, and also here we got 4a. Similarly, the length of latus rectum of this parabola is equal to the magnitude of the coefficient of y, which is 4a. The next we shall go to tangent. So this is a straight line which touches the parabola at any one point. The good thing, we already saw tangents and normals under coordinate geometry 1. So I believe this term is familiar to you. The normal, this is a straight line perpendicular to the tangent at a point where the tangent touches the parabola. So those are the terms. Now why did we go through those terms? It is because those terms are needed when you are sketching a parabola. So to sketch a parabola, you need the following. 1, you have to find the intercepts. 2, you have to find the axis or line of symmetry. So this axis is the same as line of symmetry. Then 3, you need to find the vertex. 4, you need to find the focus, and 5, you need to find the directrix, and lastly you can get the sketch. So let's see how each is got using these questions. So question 1 came from UNEB 2005 paper 1 question 7 and says sketch the parabola this and state the focus and the equation of the directrix. So this is the parabola which is given. Therefore, by comparison with this, you will realize that this 4a will be equal to 12, and this capital X will be equal to this x minus 4, and this capital Y will be equal to small y if you compare. So but our aim is to first get a, therefore shall come as that 4a is equal to 12, implying that a is equal to 3. After getting that, we shall see how to use it, but let's go through the steps we saw. The first step was getting the intercept. Intercept means that when y is 0, what is x, and when x is 0, what is y. So in this case, when y is 0, come and put your 0 here and get the value of x. So the value of x will be 4. What about when x is 0? When x is 0, put 0 here. You realize that you get a negative here, and negative square root is undefined. That is why we come here and say that y is undefined. Therefore, the intercept is for 0, which is here. X coordinate is here, y coordinate is there. Now, after getting the intercept, you have to also get the axis of symmetry, or the axis of the parabola. Any is the same. So axis of symmetry, we said you look at the part which is the variable which is squared and you equate it to 0. So when I equate this one to 0, I'll come up with y equal to 0 as my line of symmetry. Now from the line, remember we said the vertex is the point where this line of symmetry cuts the parabola. Now when you get to the point where this line of symmetry cuts the parabola, at that point we'll have y equal to 0. And the good thing we already saw that when y is equal to 0, x is 4. Therefore, we don't need to go through this step. What we need, we shall just come and state that the focus, the vertex is for 0. What about the focus? Focus, remember we saw that the standard form of the focus is a0. Okay, but that was a0 when it was capital Y squared equal to 4ax, 4a capital X. Okay, but in this case, and that was also when the vertex was 0, 0. So in simple terms, the easiest way to get the focus is you add this x coordinate to the x coordinate here, x coordinate of the vertex to the x coordinate of this standard form of the focus to get this. Then also add this y coordinate of the vertex to the y coordinate of the standard form to get this. Therefore, in this case, we know that vertex is 4, 0 and the standard form is a0. Therefore, add this x coordinate of the vertex here and the y coordinate of the vertex there. That is how you can get the focus. So I think now you realize why we had to first get the value of a. So what I'm going to do, I'm going to substitute for a here and come up with the focus as 7, 0. The next is the directrix. Directrix, remember we said the standard form of the directrix is capital X equal to negative a. But when we compare this comparison, remember we said this capital X is equal to x minus 4. So what I'm going to do, I'm going to substitute capital X with x minus 4 and also substitute a with 3 to come up with that line. Now next is to make small x the subject. So here we are case sensitive. A capital letter and a small letter, they mean different things. So this will be our directrix. Now that we have got all the terms, remember we have got the intercept, axis of symmetry, vertex, focus, and directrix. Therefore, we can now go ahead and sketch our equation and sketch our parabola. They told us to state the focus, which is there, they told us to get the equation of the directrix, which is there. So now let us sketch. So to sketch, we shall first write a summary. Now for me, I'm writing this summary, but for you don't need to write it. I'm writing it because I don't want to go back in the previous slides to keep checking what the intercept was, what the axis was, what the vertex was, what the focus was, and what the directrix was. So for my case, I'm writing this summary, but for you don't need to write it. For you, what you need is to go to sketch. Now sketching, you have the first thing to do is to draw the axes and label them. They have to be labeled: x-axis, y-axis. Then next is to get the intercept. Intercept was 40, which is here. Then next was the axis of symmetry, which was y equal to 0. Now y equal to 0 is this x-axis, so there's nothing we can write there. Then next is the vertex, which is also 40. So you come and say that this is our vertex. Then next is the focus, which is 70. So you come and put our focus, which is for 70. Then next is the directrix, which is x equal to 1. So you come and draw a line x equal to 1 and call it our directrix. And lastly is to sketch. Now when you look at this, I believe you remember that when the coefficient of x is positive, the parabola will always be in this form. So that is the only reason why we are drawing it in that form. If here there was a negative, it would have been in this form. And basically that is what they wanted. Then question 2, so those are the basics, but we shall go through a number of questions for you to master the concepts. So question 2 says, sketch the following parabola, which is this, showing clearly the focus and directrix, and state the length of the latus rectum. So the first thing to do is to code the equation of the parabola, which is given. Then next is to get the value of A. That value of A is very vital when we are sketching. So by comparison, this one is equal to this. And then we should come up with A being equal to 1. Therefore, length of latus rectum is 4A. I think you remember this formula, and we know A is 1. Therefore, in the end, we shall come up with positive 4. Then now we shall go to intercepts. Intercept means when y is 0, what is x, and when x is 0, what is y. So when y is 0, we shall come up with this. Therefore, in the end, x will be equal to 4. And when x is 0, y is undefined. I believe by now you know why y is undefined. Therefore, the intercept is for 0. What about the line of symmetry? So that was intercept. Now we shall go to line of symmetry. Line of symmetry, get this part which is squared and equate it to 0. In the end, you shall come up with y equal to 2. So that will be the line of symmetry. I believe by now you realize why I told you that it's not a must that the axes will be the lines of symmetry. Because in this case now we have y equal to 2 as the line of symmetry. Okay, after the line of symmetry, next will be vertex and focus. We shall start with the vertex. Vertex means get this value of the line of symmetry and use it to get the other coordinates. So if we have y, if here it is y, then we shall use it to get the x coordinate. So when y is equal to 2, what is x? X will be equal to 3. That means that the vertex is 3, 2. What about focus? Focus means the standard form is A0. Then on that A0 you add on your vertex, so it will be 3 here and 2 here. I already know that A is equal to 1, so substitute for A and simplify to get your focus. That was focus. What about the directrix? Directrix is given by capital X. Know that you are using capital X equal to negative A. but we saw that capital X here is equal to x minus 3. So we shall come and substitute x minus 3 equal to -1 because a was 1. And when I make x the subject, I'll come up with this, and this will be the directrix. So now we have got all. Next is to sketch. So I'll first write my summary, but for you don't need to write the summary. The next is to start my sketch. The first thing to do is to draw the axes and label them very well. So make sure you label this x-axis and this y-axis. The next is to start. This intercept is 40, so come and locate your intercept. Now next is the line of symmetry. Line of symmetry is y equal to 2, so I'll come and locate y equal to 2. The next is the vertex, which is 3, 2, so I'll come and locate 3, 2. So the x coordinate is 3, therefore 3 and this 2, you'll come up with this point, which is the vertex. The next is the focus, which is 4, 2. Focus will always lie along this line of symmetry, so that will be our focus. The next is the directrix, which is x equal to 2, so come and locate x equal to 2, which is that, and that will be the directrix. The next is to sketch. So sketching, as long as the coefficient here is positive, it will always be in this form. So if this was negative, it would have been in that form, as we already saw earlier. And that's what they wanted. Then question 3, show that the equation this represents a parabola, and hence sketch the parabola showing clearly the focus and directrix. Then state the length of the latus rectum. So like I already told you, any quadratic curve is a parabola. Therefore this is a quadratic in terms of y. Therefore it will also be a parabola, but they want you to show that it is a parabola. How? That means that they want you to show that it is in the form y squared is equal to 4ax. Now to do that, you must be knowledgeable in what we call completing squares, and we already covered completing squares under algebra. So we shall start by quoting the given equation. The next is to complete squares. Now how do they complete squares? Look at this. It is -4. Divide by 2, you'll come up with this. Okay. After that, you square it. You square everything. Y minus 2, you square it. Then after doing that, get the whole of this and square it. What do you get? You get +4, which is here, but it has to be a minus. With that, you have completed squares. But if you want to learn more about completing squares, go to the videos of algebra. You'll find that video there. Next is to collect like terms. Take this for this side to come up with this. Now this one is already in the form of that, therefore it is a parabola. So that is how you can show that the given equation is a parabola. So now we shall go to the hence part. Hence part, they want you to sketch the parabola and show clear the focus, directrix, and then state the length of the latus rectum. So by comparison, when I compare this with this, you realize that this 4 is equal to this 4a. Therefore, a will be equal to 1. And the length of the latus rectum is 4a. Therefore, 4 times 1 will give you 4, which is the length of the latus rectum. Now we have to sketch the curve, but for you to sketch the parabola, you need some parameters. So let's start with the intercepts. So when y is equal to 0, you'll come up with x equal to 0. What about when x is equal to 0? It means that we'll come up with this. Therefore, put square root on both sides, we'll come up with plus or minus 2 here. Then make y the subject, you'll come up with two values of y equal to 0 and y equal to 4. Therefore, the intercepts are 0, 0 and 0, 4. What about the line of symmetry? The line of symmetry, you'll come and equate this to 0. You'll come up with y equal to 2 as the line of symmetry. Then for the vertex, it means that when y is equal to 2, what is the value of x? X will be equal to -1. Therefore, the vertex is -1, 2. What about the focus? Focus, the standard focus is A0, so you add on the vertex. So this is -1, put it here, and this 2, put it there. The good thing, we know the value of A is 1, so the focus will be 0, 2. Then also the directrix. Directrix is capital X equal to -A. Therefore, capital X is x plus 1 and A is 1. So we come up with that and make small x the subject. It will be x equal to -2 as our directrix. So now we can sketch. The first thing to do is to draw the axes and label them. X-axis and y-axis. And this is the origin. The next is to locate the intercepts. 0, 0 is already here. Then now 0, 4 will be there. The next is the line of symmetry, which is y equal to 2. So this will be the line of symmetry. And then the vertex was -1, 2, which is there. The next will be the focus, which is 0, 2, which is there. And then the directrix, which is x equal to -2, which is there. And lastly is to sketch. So to be in this form, because the coefficient of x was positive. And that's what they wanted. Then now shall go to question 4. Question 4 says they show that the equation this represents a parabola, and hence sketch the parabola showing clearly the focus and directrix, and state the length of the lattice rectum. So here it means that you have to complete squares. So when I complete squares, I'll divide throughout by 2. Then after that, the reason why I divide the third by 2 is to make this coefficient of x squared +1. Then after that, I can now complete squares. So when I complete squares for this part, I'll come up with this. I believe by now you know how to complete squares. That video is available under the videos of algebra. So when I multiply third by 2, I'll come up with this. And then take this to this side to come up with that. So then when I rearrange, I'll come up with this, because the square you should start with a square. Then we shall conclude that this is in the form x squared. Now it is x squared because this term of x is the one which is squared. X squared is equal to 4ay. Hence it is a parabola. So we have shown. Now next is they want you to sketch the parabola showing the focus and directrix and the length of the lattice rectum. So this means that capital X is equal to x minus 1, and capital Y is equal to y plus 2, and 4a is equal to 1/2. So by comparison with that, 4a is equal to 1/2, therefore a will be equal to 1/8. Therefore length of lattice rectum will be 4a, which is 1/2. Then the intercepts, because for you to sketch you need some parameters. So the intercepts, when y is 0, what is the value of x? X will be 0 or 2. What about when x is 0? Y will be 0. Therefore the intercepts are 0, 0 and 2, 0. Then the line of symmetry, it means that you have to equate the whole of this term which is squared to 0. And you'll come up with x equal to 1. Now for the vertex, when x is equal to 1, what is y? Y will be -2. That implies that the vertex is 1, -2. What about the focus? Focus, the standard one now here it has interchanged, because the standard vertex of f0 was for y squared equal to 4ax. Now here we have x squared equal to 4ay, therefore it has to interchange. Instead of being a0, it will be 0a. After that, we have to add on the vertex. So vertex, this one comes here and this one comes here. The good thing, we know the value of a, so come and substitute for a, then simplify to come up with this as the focus. Then the directrix, now we shall use capital Y equal to negative a, because here it was x squared which was squared, x which was squared. Then we already know that capital Y is equal to y plus 2, therefore when I make y the subject, it will be negative 17 over 8. And that will be the directrix. So now that we know those parameters, we can sketch our curve. So this is a summary for me. For you don't need to write it. For you, what you need is the sketch. So sketch, you have to draw the axes and label them. So make sure you label the axes. Then you should start. The origin is here, and this one 20 is here. The next is the line of symmetry, which is x equal to 1. The next is the vertex, which is 1, negative 2. And next is the focus, which is here. And next is the directrix, which is there. Then now we shall sketch our curve. So because the quotient was positive, the quotient of y was positive, it implies that it will have a minimum point. Then now shall go to question 5, which came from UNEB 2017, paper 1, question 7, and says the equation of a curve is given by this. Part A, show that the curve is a parabola, and part B, find the coordinates of the vertex. So showing that it's a parabola, we have to complete squares. The first thing to do is to collect like terms. So when I complete squares for this, I'll come up with this part. Then simplify and collect like terms, I'll come up with that. Therefore this will be in the form y squared equal to 4ax, and therefore it is a parabola. Then for the vertex, you have to first get the line of symmetry. Line of symmetry means you square this part which is squared equal to 0 to come up with the value of y. Therefore the value of x will be, when y is 3, what is the value of x? X will be negative 20. So what does that mean? It means that the vertex is 3, negative 20. So now shall go to parabola and a straight line. So consider a line, a straight line y equal to mx plus c, and a parabola y squared equal to 4ax. Substituting for y into equation of the parabola will come up with this. So where there was y, you put the mx plus c. Then expand, you'll come up with that. Rearrange, put x squared alone, x alone, and constant alone. So that means that when I compare with the general quadratic equation, the a will be this m squared, b will be this in bracket, and c will be, capital C will be that. We're using capital letters such that this c does not collide with this c in the expression, and also this a does not collide with this a. So when you see a and c, it implies that you have to use capital letters so that they don't collide. Now from there are 3 things we need to note, just like we did under circles. One is that when the discriminant is greater than 0, then the line cuts the parabola at 2 distinct points. Therefore that line is a chord to a given parabola. Then when the discriminant is equal to 0, it implies that the line just touches the parabola at only one point, implying that that line is a tangent to the parabola. And when the discriminant is less than 0, it implies that the line is neither cuts nor touches the parabola, implying that it is neither a chord nor a tangent. So then now let's go through some of these questions. Question 1 says, prove that the line y equal to 2x plus 2 touches the parabola this, and find the coordinates of the point where this occurs. So they want you to prove that it touches, in other words, they want you to prove that's a tangent. So come and write this line, then substitute this equation of the tangent. So the equation of the line given. So expand, collect like terms, and reduce by 4 to come up with that. Then from there we shall come and say that for the line to touch the given parabola, the discriminant must be equal to 0. I think realize that now we are using small letters of a, b, and c, because here there is nothing like a, b, and c in the expression. So I'll come and substitute for b, for a, and also for c. So you'll come up with 0 equal to 0, which is true, and because it is true, it implies that the given line is the tangent to the parabola. They also wanted the point where this occurs. So the point where this occurs, the x value will be given by this quadratic formula, and already saw that the whole of this is equal to 0. Therefore you remain with this and that, which is 1. Therefore the value of x is 1. And when x is 1, you can go to the equation of the tangent and get the value of y. So that means that the coordinate will be 1, 4, and that's what they wanted. They now shall go to question 2. Question 2 says, prove that the line this is a tangent to the parabola this, and hence determine the coordinates of the point of contact. So this is almost the same, but we shall do it for the sake of mastering the concept. So that is the equation of the parabola, substitute for y, expand, collect like terms, and then compare. So for the line to be a tangent, the discriminant is equal to 0, substitute for a, b, and c, then you'll come up with 0 equal to 0, implying that's true. Therefore you conclude that the given line is a tangent to the parabola. Then for the point of contact, it implies that x is equal to this. This is the bulldozer method, therefore substitute. The good thing we know that the whole of this discriminant is equal to 0. Therefore in the end we shall come up with x equal to 1. Then from this equation of the line, you can be able to get the value of y, and then you conclude that the required coordinates are 2, 4. Then question 3 says, prove that the line this casts the parabola this at 2 distinct points, and find the coordinates of these 2 points. So first of all, this is the given equation parabola, then substitute for y, expand. So the procedure is the same, expand and collect like terms. Then compare with the general quadratic equation. The discriminant must be greater than 0 for it to cut at 2 distinct points. So come and substitute for a, b, and c, then simplify, I'll come up with this. Therefore this is greater than this. The question is it true? Yes, it is true. And because it is true, then you can conclude that the line cuts the parabola at 2 distinct points. Then at the point where this occurs, x is equal to this. So come and substitute the whole of this. We already saw it is 2, 5, 6. So that means that x is equal to 2 or x is equal to 18. Then from this equation of the line, when x, you'll be able to get the corresponding values of x, of y. When x is 2, y is that, and when x is 18, y is that. Therefore you will conclude that the coordinates of the point of contact are 2, 8 and 18, 24, and that's what they wanted. So now we shall go to general point of a parabola. Now this general point is also available in the mathematical table. So if you look at your mathematical logbook, under parabola there's this part of parametric form, and it is a.t squared to a.t. So t is a constant, a is a variable, sorry, a is a constant, and which is here, then t is the variable. So it can be t, it can be p, it can be q, depending on what you want, as long as you remember that it is a variable. So you come here and say that the points on a parabola are in the form this, where a is a constant and t is a variable number. So now we shall go to tangents and normals to a parabola. So I believe by now you know what a tangent is and what a normal is. So given a parabola this, the equation of the tangent and that of the normal to the parabola at point this, which is a general point on a parabola, can be got as follows. So you know this equation of the parabola. The first thing to do is to differentiate both sides. So differentiating this gives you 2y dy dx, and differentiating this gives you 4a. When I make dy dx the subject, I'll come up with the gradient function as 2a over y. Then from there, this is the gradient function. Now to get the gradient of the tangent, you substitute for y. Therefore at this point, y is equal to 2at. Therefore come and substitute for y here to come up with the gradient of the tangent, and to be 1 over t. Now using this point and this gradient, so we already covered under coordinate geometry 1 how to get the equation of a line given a point and the gradient. So in this case, that's the same knowledge you're going to use. You have a point and you also have the gradient. So to get the required equation of the tangent will be got in that form. So this change in y and change in x all equal to the gradient. Cross multiply, rearrange, and make y the subject. So this will be the equation of the tangent. Now t and a remain because even in the general point t and a was available, was included, and this is what we call the general equation of the parabola at a point this. So if this variable is q, it implies that where there is t you put q, and if the variable is p, it means that where there is t you put p. So now we shall go to get the normals. What we need to remember is that the normal and the tangent are perpendicular to each other, and the product of the gradients of perpendicular lines is equal to -1. What does that mean? It means that gradient of the normal will be equal to -1 over gradient of the tangent, and the reciprocal will be, now the reciprocal is t, then this negative makes it -t. Now using this point and the gradient this, I can be able to get the required equation of the normal. By using that formula, then cross multiply, then open brackets and make y the subject, and that will be the equation of the normal. So with that knowledge, shall go through a number of questions. Question 1 came from UNEB 2016, paper 1, question 14, and says the points this and that are on the parabola this. OP is perpendicular to OQ, where O is the origin. Show that T1, T2 plus 4 is equal to 0. So we have they said OP and OQ are perpendicular, meaning that the gradient of OP multiplied by the gradient of OQ will be equal to -1. And O is the origin, which is 0, 0. So when I use the points OP, I'll come up with this change in y over change in x, and using points OQ, I'll come up with points change in y over change in x. Product of those gradients will be equal to -1. Now when I simplify, this is that and this is this. Then also you realize that this a cancels with this a, and this a cancels with this a. Then 1t cancels with 1t here to remain with t1, and here 1t2 cancels with 1t2 will remain with t2, 1t1, t2. Therefore, the denominator will have t1, t2, which is this, and the numerator will have 2 times 2, which is 4. Cross multiply, then put everything on one side to come up with what they wanted. So now we shall go to question 2, which came from UNEB 2001, paper 1, question 12b, and says, find the equation of the normal to the parabola this at this point and determine its point of intersection with the directrix. So we are given this, we shall first differentiate both sides to come up with that. I believe you already saw that. Then make dy dx the subject, and that will be the gradient function. Then at this point, y is equal to 2at, so substitute for y to get the gradient of the tangent at that point. Therefore, the gradient of the normal is the negative reciprocal of the gradient of the tangent, and to be negative t. Now, using this point and the gradient this, so here there's a negative, the required equation of the normal will be that. So remember to put here negative. Then cross multiply, open brackets, and make y the subject. So the directrix is x equal to negative a. I think we saw that under in your mathematical logbook. Now from this point, which is here, we shall say that when x is equal to negative a, we shall be able to come up with the value of y. So substitute and simplify, y will be that. Therefore, the required point of intersection will be negative a and this point, because they told you that it intersects the directrix. Then question 3 came from UNEB 1994, paper 1, question 7, and says, prove that the tangents to the parabola this at the points this and this meet at the point T, which is given by this. So let's first do that before we go to Roman 1. So this is what is given. We are going through the same procedure. Differentiate both sides, then make dy dx the subject, and that will be the gradient function. Therefore, at this point P, y is equal to 2ap, so come and substitute, they get the gradient as 1 over p. Then using that point and the gradient this, the equation of the tangent at P will be given by that. So cross multiply and simplify. So that is equation 1, and similarly, the equation of the tangent at this point Q, it means that where there is P, you put there Q to come up with that as equation 2. So at the point of intersection, equation 1 is equal to equation 2, therefore come and equate the 2. Then collect like terms, put this one this side to come up with this, and also bring this one this side to come up with that. Then get the LCM for this, you come up with that. Then you realize that this numerator here can cancel with this to come up with this. Therefore, make x the subject, you come up with x equal to AP2. So the good thing, you have got the x coordinate, which is similar to the one in the question. Now we also need to get the y coordinate. So from equation 1, substitute for x to come up with this. Therefore, the point of intersection is this as required. Now we shall go to Roman 1. Now Roman 1 says, if M is the midpoint of PQ, prove that TM is bisected by the parabola. So let R be the midpoint of TM. So we shall need a sketch, draw the axes and label them. So the axes have to be labeled. Then from there we shall sketch our parabola, which is y squared equal to 4ax. Then locate point P and also locate point Q and join the two. Then draw a tangent at P, draw a tangent at Q, then they meet at point T. And this is M. And we say that let R be the midpoint of TM. Now what they wanted you to show, they said that this one is bisected by the parabola, meaning that the midpoint of this line TM must lie on the parabola. That's what they want. So you come and say the midpoint of PQ is given by this, average of the x coordinate and average of the y coordinate. You will come up with this. And the midpoint of TM is given by this, average of the x coordinates, average of the y coordinates. You simplify to come up with that. Now using point T and M, the equation of the line TM will be given by that. So changing y by changing x, they're equated. Then when you simplify, you'll come up with this. So you realize that this one, the whole of this is the same as this, meaning that you will come up with 0. So when you come up with 0, it implies that y will be equal to a in brackets p plus q. Now at the point of intersection of line TM and the parabola, this equation must satisfy the equation of the parabola. So put the y coordinate there and then see if you get the same x coordinate as we got before. Now the intersection is this, which is equal to the midpoint of TM. What does that mean? It implies that TM is bisected by the parabola because the coordinates are the same. Then Roman 2, so Roman 2 says, if P and Q vary on the parabola in such a manner that PQ is always parallel to the fixed line y equal to mx, show that T always lies on the fixed line parallel to the x-axis. So gradient of PQ is given by changing y over changing x, which in the end, when you simplify, you come up with 2 over p plus q. But line PQ is parallel to line mx. What does that mean? It implies that they have the same gradient. That is why this gradient can be equated to this gradient, as you see here. Therefore, p plus 2 is equal to 2 over m. Then from the equation of the line TM, we saw that that was the equation. So what I'm going to do, I'll substitute for p plus 2 to give you this. Therefore, y is equal to 2a over m. Now, since a and m are constants, it implies that t lies on the fixed line parallel to the x-axis. And that's what they wanted. So question 4 came from UNEB 1993, paper 1, question 11, and says, part A tangent from the point T, which is that, touches the curve this. Find Roman 1 the equation of the tangent, and Roman 2 the equation of the line L parallel to the normal at this passing through this. So Roman 3 the point of intersection X of line L and the tangent. So let's start with the Roman 1. We have the equation of the tangent at this point of on this curve or parabola. So this is the equation of the parabola. Differentiate both sides, make the y dx the subject to get the gradient function. Then at this point y is equal to 2t, so substitute for y to come up with the gradient of the tangent as 1 over t. Now using this point t and the gradient 1 over t, the required equation of the tangent will be given by this. I believe you know where the statement comes from. So cross multiply and then simplify to make y the subject. So now shall go to Roman 2. So Roman 2 says find the equation of the line L parallel to the normal at this point and passing through 1, 0. So remember this point is the same as point capital T. So parallel lines have the same gradients, meaning that the gradient of the normal is the same as the gradient of the line L. Therefore we shall come here and say that gradient of the normal is the negative reciprocal of the gradient of the tangent, which gives you negative t. Now since parallel lines have the same gradient, imply the gradient of line L is the same as is also equal to negative t. Now using this point, because they told us the line L passes through this point, and now you have got that it has a gradient negative t, so we can easily get the equation of line L. So cross multiply and make y the subject. Then Roman 3 says find the point of intersection x of line L and the tangent. So the whole thing, we have the equation of the tangent and also have the equation of line L. So we need to solve them simultaneously. So at the point of intersection, these two are equal. Then when you realize this and this cancels, you remain with this, and therefore take this one this side. Most students, what they will do, I think you realize that here, if you just cancel this, then the solution will be vague. So take everything on one side and factorize. Then either x is that or this is that. So if you just cancel, it means that you will have missed this part of x equal to 0, which is not okay. But we know that this one can never be equal to negative 1, because square root of a negative is impossible or is complex. Therefore what we take is this one, which is x equal to 0. Now when x is equal to 0, y will be equal to this. Now here use any of the two equations. You can use this one or you can use this. It will all give the same answer. Therefore the point of intersection will be 0t, and that will be point x. So now shall go to part B. So part B says a point P is equidistant from x and t. Show that the locus of P is given by that. So equidistant means equal distance. That means that xp is equal to distance pt. And the good thing, we already know how to get the distance between 2 points. So you come here and say that we have these 3 points, xpt. Therefore xp is equal to distance pt. So distance between x and p is this, between p and t is that. So what I'm going to do, I'm going to expand. This gives you that, and this is that, this is that, and this is this. Then square both sides to come up with that. Collect like terms to come up with that. Then rearrange in the required format to come up with that. Then question 5 says, show that the equation of the tangent to the parabola this at this point is that. So this is a parabola, differentiate both sides, get the gradient function, and then at this point substitute for x and y. So y is that, so come and substitute for y to come up with this. Therefore, using this point and this gradient, I'll be able to come up with the equation of the tangent. From this expression, I'll cross multiply and then open brackets and simplify to get this format which they want. So I'll have to simplify until I get this which they want. So 2a is common, I can factorize it out to get this, and that was what was required. So now I shall go to equation of a chord to a parabola. So I've seen tangents and normals, now we shall go to chords. So consider 2 points P and Q on the parabola this. A line joining these 2 points is what we call the chord, and this equation is what is known as the equation of the chord. So using 2 points P and Q, the equation of chord PQ is given by this. So gradient, you equate the gradients. So the gradient, this is the gradient using points P and point Q, and this is the gradient using point P and the variable point xy. So when I cross multiply, I come up with that. Simplify this, and this a can cancel to remain with that. Then also this is the difference of 2 squares, that's why you can see this. Then from there, this and this can cancel, remain with this alone. Then from there I can open brackets now. This y times this gives you this, and this times this gives you that. Then here this times this gives you this, and this times this gives you that. So when I rearrange, I'll come up with that. Take all this one, take this one this side to come up with that. Open brackets to come up with that, and therefore I simplify to come up with this as the equation of a chord. So basically that's how they get the equation of a chord. You have to use 2 points and get the equation of a line passing through those 2 points. So with that, let's go through some questions. Question 1 came from UNEB 2014, paper 1, question 2, and says, a focal chord PQ to the parabola this has the gradient m equal to 1. Find the coordinates of the midpoint of PQ. So let's first draw a sketch. Label the axes well, then sketch the parabola. Then the side points P and Q. Now we are using these ones because these are the general points of a parabola. I think you remember those general points. So this is what they call a chord, the line joining these 2 points. Now because it is the focal chord, it has to pass through the focus of the parabola. So now given this, it implies that I want to first get the value of a. Therefore when I compare, 4 will be equal to 4a, implying that a is equal to 1. That means that this point will now become this, and this point will now become this, and the focus is now 1, 0. So the gradient of chord PQ, I'll use these 2 points and change in y over change in x. But now here I'm not putting a because we already saw that a is equal to 1. And also I told that the gradient is equal to 1, that's why I'm quoting it to 1. So when I cross multiply, I'll come up with that, and then this can cancel with this to remain with this. Also, gradient of PQ is equal to gradient of QS, because all those 3 points are on a straight line. So gradient of PQ is this, gradient of QS is that. So cross multiply still. Then from here I realize that this is difference of 2 squares, that's why I put this. Then from there I realize that this and this can cancel, that's why I remain with this. Then open brackets, and then you'll come up with this. P2 is equal to -1. Therefore the midpoint of P2 is equal to this average of x coordinates and average of y coordinates. But this one can be reduced. I think remember that under sum and product of roots is the same as this. Therefore that means that this p plus 2 we saw that is equal to 2, and now this product of P2 we saw that's -1, so this here we shall put there -1. This p plus 2 will be just 2, so simplify, I'll come up with 3, 2 as the midpoint of P2. Then now I shall go to question 2, which came from UNEB 2001 paper 1 question 12A, and says Roman 1, find the equation of the chord through the points this and that of the parabola this. Then 2, show that the chord casts the directrix at this point at y equal to that. So given 2 points, I can be able to get the equation of the chord, which is the same as the equation of the line passing through those 2 points. So this is the change gradient when I'm using points this and the variable point xy, and this is the gradient when I'm using these 2 points. Cross multiply will come up with that. Then here I shall remember that this is the difference of 2 squares, so we'll come up with this. And from that we shall realize that this and this can cancel, and also this a can cancel. So let's do that on the next slide. So you shall come up with that. Then this y times the whole of this gives you this, and this one times the whole of this gives you that. Then here 2 by this gives you this, and 2 by this gives you that. So when I simplify, I'll come up with that, and then I'll come up with this. So now when we go to Roman 2 says show that the chord cuts the directrix at when y is equal to that. Now the good thing, we already know that directrix is equal to x is equal to -a. Therefore when x is equal to -a, come and substitute in this which you got here to come up with the value of y. So I'm going to simplify until I make y the subject, and that is what they wanted. So now I shall go to question 3, which came from UNEB of March 1998 paper 1 question 13, and says P and Q are 2 points on the parabola this. P2 is a focal chord, that means it passes through the focus. Prove that P2 is equal to -1, and hence that if the tangents at P and Q intersect at T, the locus of T is given by x plus a equal to 0. Then PM and QN are perpendiculars onto x plus a equal to 0, and S, which is the focus, is a0. Prove that MSN is equal to 90 degrees and is equal to PTQ. So we shall start by making a simple sketch. So draw the x-axis and label them: x-axis, y-axis. Axis must be labeled. Then that will be the parabola. Then we have 2 points P and point Q, and the line joining them is the chord. Then there's a tangent at P and also a tangent at Q, and they meet at point T. But this is the focal chord. P2 is the focal chord, meaning it passes through the focus. Therefore, gradient of P2 is equal to gradient of QS. So I'll come and substitute this gradient of P2, gradient of QS, cross multiply, simplify because A is common. Then cross multiply. Then From there, we realize that this is the difference of two squares, put it here. So you remain with that, because this and this can cancel. Then expand and then simplify to come up with that which was required. So we have proved that P2 is equal to -1. Then they said hence that if the tangents at P and Q intersect at T, the locus of T is given by x plus a is equal to 0. So we shall come and say that for the hence part. Why is that? Our aim is to get the equation of those tangents. So differentiate both sides, then gradient function is that. So at this point, and y is equal to that, therefore gradient of the tangent is 1 over p. Then using this point and this gradient, I can be able to get the gradient of the tangent at point P from this. Cross multiply, then simplify until you make y the subject. That is equation 1. Now similarly at point Q, gradient is that. Sorry, the equation of the tangent is that. Now at the point of intersection, the equations are equated. Collect like terms like this one this side, then get LCM, this and this will cancel to remain with that. Therefore x is equal to AP2. But P2 is equal to -1, therefore x is equal to a times -1, therefore x is equal to, sorry, x plus a is equal to 0, because when this becomes -a, take it this side, it becomes x plus a equal to 0. And that's what they wanted. So we are done with this. Now we shall go to this other part. They said PM and QN are perpendiculars on 2x plus a equal to 0. S is the focus. Then prove that MSN is equal to 90 degrees and also PT2 is equal to 90 degrees. So here what we are going to do, we are going to redraw the sketch we have already drawn and then add on some information which has just been given. So previously I saw this is P, this is Q, this is the chord, this is the tangent at P, tangent at Q, meeting at point T. So that's what we saw previously, but now they've told us that they want you to show that this one is equal to 90 degrees. That is PTQ. And also this, the perpendiculars from through P to meet this line x plus a equal to 0 meets at M, so that will be point M, and also perpendicular to this line through Q meets at N, therefore that N will be that. So I think we realize that we're using same y coordinates because this is the horizontal line, and also we have same y coordinate because the horizontal line. But the x values are changing, and the x value is got from this, because here x is equal to -a. That is why you put here -a and here -a. Now they also want you to show that this is the focus, and they want you to show that MSN is 90 degrees. Okay, so let's get started. So for PT2 to be equal to 90 degrees, the gradients, these tangents must be perpendicular, meaning that the product of their gradients must be equal to -1. So when I multiply the gradient of PT with the gradient of QT, I'll come up with this was gradient of PT, gradient of QT, I'll come up with this. But the good thing, I know that PQ is equal to -1, therefore I'll come up with this product as -1. Therefore they are perpendicular. What about for MSN to be perpendicular? It implies that tangents MS and NS must be perpendicular. Therefore, gradient MS is that and gradient NS is that. I'll have to multiply and see if I'll come up with -1 at the end. So I'll come up with that PQ, and good thing I know that PQ is equal to -1, therefore the product is equal to -1, implying that this is also 90 degrees. So now we shall go to parabola involving loci. So here there's nothing to write because everything about loci was already written under the video of loci in geometry. So question 1 says a line parallel to the x-axis cuts the curve this at P and the line this at Q. Find the locus of the midpoint PQ. So here we shall need something like a sketch. So draw the axes have to be labeled. Always remember to label the axes. Then this is the parabola, so to be of that shape because the quotient of x is positive. Then there's this point P, and there's this line x equal to -1, and there's this point Q. Therefore, they want the midpoint of PQ is that, and that's the locus they want. So I think we realize that here we have used small x and here we use small capital X. So we must be conscious of that. Now this midpoint is given by the average of these two. So this plus this gives you this over 2. Then this plus this, this plus this gives you this over 2. So when I compare capital X is equal to this, capital X is equal to this, which is here, implying that small x is equal to this. Now, why am I making small x the subject? Is because the locus they want is in capital letters. Therefore, I have to make small letters the subject so that they can be eliminated. Similarly here, I'll come up with small y equal to capital Y. Therefore, from this equation of the parabola, I'll come and substitute for y and for small y and small x to come up with that, then open brackets to come up with this as the required locus. Then question 2 says the normal at point P, which is that on the parabola this, meets the axis of the parabola at G. Axis means line of symmetry. So Roman 1, show that the coordinates of the midpoint M of PG is this. I think let's start with that. So by comparison with this, 4A will be equal to 12. Therefore, A is 3. Implying that P is equal to that. Because we are given in the question we are given that P is equal to e.t.c squared and 2a.t. Therefore, when A is 3, it implies that now this will become 3t squared and this will become 2 times 3, which is 6t. That is why you see it here, 3t squared, 6t. Now, given this equation, I'll differentiate both sides, then get the gradient function, and at this point now y is equal to 60, so substitute for y to come up with this as the gradient of the tangent. Then gradient of the normal is the negative reciprocal of the gradient of the tangent, so it will be -t. Now using this point and this gradient, I'll come up with the equation of the normal. So from this expression I'll cross multiply, then open brackets and simplify to come up with that. Now at point G, y is equal to 0. Therefore, substitute for y equal to 0 and look for getting the value of x. So x will be equal to that. Therefore, g will be that. Now, the midpoint of PG will be equal by the average of the x coordinates and average of the y coordinates. So we'll come up with this, and that was what was required. And now we shall go to Roman 2. Roman 2 says, hence show that the locus M of M as P moves around the parabola is this. Now from this, we know that x is equal to this and also y is equal to this. Now locus means we are going to eliminate this variable number. So here from this, when I make t the subject, I'll come and substitute it here. And by that, I will have got the locus. So when I substitute, I'll come up with that. Next thing to do is to simplify and get the required expression as it was given in the question. And that's what they wanted. So now we shall go to question 3, which says a variable tangent to the parabola this meets the circle this at P and Q. Find the locus of the midpoint P and Q of P and Q. So here we shall need a sketch. So we shall draw the axes and label them. Remember to label the axes. Then I'll draw my parabola and also my circle. The center of the circle is 0, 0. So I'll draw a tangent at this point R, which lies on the parabola, and cast the circle at points P and Q. Then this M is the midpoint of P and Q, and by geometry that will be at 90 degrees. Now why is it 90 degrees? It's because from here to here is the radius, and also from here to here is the radius. Therefore, that means that triangle POQ is isosceles. And because it is isosceles, it means that when you draw a perpendicular, it will pass through the midpoint. So you come here and say that let the variable tangent be in the form y equal to mx plus c. Given this equation of the parabola, substitute for y, then open brackets, then rearrange to come up with that. Then by comparison, we shall come up with capital A as that, capital B as that, and capital C as that. For the line to be a tangent to the given parabola, discriminant must be equal to 0. So substitute for A, B, and C. Then from there, open brackets, expand this to come up with this, and take this one this side to come up with that. Then from there, realize that this and this will cancel to remain with these two terms, which are this. Then 16 is common, so it can factorize out and it cancels out. Then also 1a will cancel to remain with this. Therefore, c is equal to a over m. Now the equation of the variable tangent is given by that, and call it equation 1, where m is the gradient of the tangent. Now by geometry, the midpoint of PQ is the foot of the perpendicular from the center O of the circle to the variable tangent PQ. I think I've already explained that. So gradient PQ times gradient OM is equal to -1. That's the condition of perpendicular lines. So substitute for the gradients and equal to -1. Then make M the subject, you'll come up with M equal to -x over y. Now we have two equations both having a variable value, which is M. So my M is to eliminate that variable M, and that will be, what I get will be the locus. So I'll come here and say that when the locus is got by eliminating m, therefore substituting equation 2 into equation 1, I'll come up with that. Multiply followed by the LCM, which is xy, to come up with that. Simplify and then make y the subject, and that would be the locus they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on ellipse, which is also under conic sections. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on ellipse has been uploaded. Otherwise, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.